Hello everyone, this is Razani, so you can call me Zeyfra, and today we are going to be solving an algorithm in JavaScript using JavaScript to number sum problem. So this is a LeetCode problem and it is asked quite often in many interviews. So the question is, write a function that takes in a non-empty array of distinct integers and an integer representing a target sum. If any two numbers in the input array sum up to the target sum, the function should return them in an array. The order doesn't matter here. So now let's see how would we go about doing this. First of all, let's suppose we have this input. So we have 3, 5, minus 4, 8, 11, 1, minus 1, and 6. All right. And we have the target sum as 10 now. And looking at this, you can probably tell that if you want to find like two numbers that sum up to 10, we could say that 11, let me just erase that or just do this. We can say that 11 and minus 1 do add up to 10. So we can say that this is the pair of number that we are looking for in this array. Now, there are some ways to do this. One of them is a brute force kind of way, which is not very optimal, but we can actually use two for loops here, and we can take one item for the first for loop and go through all the items in the second for loop and see if that gives us the target sum. So we will write two for loops to do this non-optimal way, so that this would be non-optimal. But we don't want a non-optimal solution. We don't want a brute force solution. Most of the time, interviews want you to give you the most optimal solution by time complexity and stuff. So let's do it in a more optimal way, and that would be, by the way, some questions might ask you to give the indexes. So we could say the indexes would be 0, 1, 2, 3, 4 for this, and 5, 6 for this. So don't worry about that. I'm actually going to go over how to get the indexes as well. It's not that hard. It's just a one line of change. So for now, let's see what we can actually do to make this more optimized, more better with the time complexity. So what we will do is that, let me just clear this out, because we will clear this out like this, right? So let me just clear this space, and we are going to actually use a hash map. In JavaScript, the hash map could be defined like this in a variable. We could say that the hash map looks like this. So it's basically just an object, and we can use this object to keep track of the numbers that can actually add up to the target sum that we have here. For example, we can make like two variables in our code. The sort of like current is to nothing. Basically, current is the number that we have here, which is, and let's assume it's x, because we are actually going through a loop. So for example, if the current is x, because we are looping through the whole array once, and the target is the number we have up there, which is 10, and we are going through the loop once, and we are going to check what number actually sums up to the target number. So if we can break down this into a simple mathematical equation, it would be x plus y equals to 10, right? That feels pretty simple. 11 plus minus 1 equals to 10. I think we can all agree on this. So what do we have to do here? We know x, we know the value of x because we are actually looping through it, but we do not know the value of y, but we do know the value of 10. So we can actually to get y, we can do simple mathematical operation here, which is y equals to 10 minus would be whatever the value of x is. And then, for example, if it's y is equals to 10 minus 11, we will get minus 1. And when we do have minus 1, we have actually found the value of y, because y was minus 1. So to do that, we can actually go through the entire loop once, and we will just store going through 3, 5, 4, 8, 11, 1, minus 1, and 6 once in the entire loop. And we will, whenever we do the operation of difference, which is this, y is equals to 10 minus 3. So for example, we did y is equals to 10 minus 3, and we got 7. Then we'll check if this 7, if it doesn't exist in our hash map, then we will add the value of x. So we will add the value of 3 in our hash map. So we will say, hey, 3 is added here, and we can add the index that we found 3 at, so that would be like 0. We don't really need to put 0 here. We can actually use true, but this will help us in finding the index of the items, in returning the index of the items. And then let's go one more step ahead. So we will say 10 minus 5. What is that? It's 5, and we'll see if 5 exists in the table. It doesn't exist in the table, so we'll add the value of x, which is 5, and the index at which it was, that would be 1. Let me just get some space here. This is actually getting a little bit crowded. So we found 3, we said it's at 0. We found 5, we said 0. Sorry, it's at 1. And then we will go for minus 4. Now what is 10 minus 4? It actually becomes plus 4, and that's 14, and 14 is not table, so we'll add minus 4 here and say, hey, add position 2. Similarly, we'll go for I might speed this up here, but we'll go for 8. We'll say, hey, it is at location 3, and if we do 10 minus 8, it is 2, which is not what we're looking for, because 2 doesn't exist in our table here. So we'll go add one more. Then we'll go ahead to find 11. So we'll say 11 is at position 4. And what does this make? It makes 10 minus 11. It makes minus 1. Minus 1 doesn't exist here. Not yet, at least. So we do this, and then we go for 1. So this is at position 5, and it is making 9. It just doesn't exist here. So that's why we are actually going ahead. And then we get to minus 1. Now, minus 1 is 10 minus 1, which makes it 10 plus 1. 10 plus 1 is actually 11. And we look into our object here, and we do find 11 here, right? So when we do 10 minus 1, which is 10 minus 1, we get 11, which is y. And we look for this number inside our hash table that we were actually managing, and we do find 11 here. So this means that we can actually stop our loop here. So we don't actually need to go ahead more, because we have found a number that we were looking. When we have found 11, we can stop here. So what we'll do is then we'll return an array that has the value. The difference is 11, right? We're going to take 11, and we are going to check what's the position here is. That's 4, so we can just pretty much return the 11th number. So we return 11th term, the current index that we are at. So we are at this value, right? So this is the current. So we return this as this. Happens for the case where the code asks you for the actual numbers that sum up to the target value. But what if it asked you to return the indexes instead? That's pretty simple. That's pretty simple. You just have to in the object, we are storing the indexes here as well, so you don't actually have to look this number up again. You can just use the value part of this, and you can pretty much just return the indexes from here, and we will see in the code how we'll do that. So you can return the 4, and you can return the 6. Okay, that's pretty simple, pretty straightforward, and we'll go looking into the code more, and that will be much more helpful in understanding the solution. By the way, the solution is actually very optimized for the time complexity, but we are using an extra object here, so this will actually take up some more space. And let's just see this running in the code now. So hopefully the screen is visible to you guys, and it is actually readable. So what we are doing here is pretty simple. We are actually making an object, like I explained in made an object, which is a hash map, and we will use that object in a for loop. So what we'll do is that we're going to loop through all the numbers. We'll say, hey, for let I in numbers, for an item in numbers, do this operation. And what we are doing is that we are first taking the difference like we did here, which is y is equals to 10 minus x, right? So this is what we're doing. there as well. We're taking y, which is named difference, and that is the target we're getting, and this is the actual number that we're getting. We're going to take the difference of this, and then we're going to check if this difference exists in our object. If it does not exist in our object, then we are going to pretty much save this number, whatever this number is. So in our case, in the first case, it would be 2. Then 2 would be saved inside the object, and the index of 2, which is 0, will be saved here. It will go through the loop until it finds the difference actually inside the object. When it does exist, then it will stop the loop and it will return the index value of this, which is object difference. So the difference in our case was when it was actually 11 in our case, then we found it inside our object and we returned the index. So right now in here we are actually just returning the index of the value. And we are also returning the index of the current number that we actually used for the difference. And when that's returned, it would run, and let's see what the results would be for it. So it is passing every case, and let's see how much percentage it is actually beating. So it is actually beating 97.48% of answers are out there. That's pretty good. That's actually pretty good. All right. And if your question actually requires you to give out the actual number instead of the indexes, then it is pretty simple. You just have to do this. So you have to actually just go into the nums array and get the index of the number, because this will have the index here, and this will have the value of the other number. So that would be how you would get actual numbers instead of just indexes. All right. That was all. Hopefully you guys understood it. I tried to make it as much sense as possible. And before we forget, let's just see what the time complexity of this would be. So the time complexity of this whole solution would be O of n. What am I doing here? O of n. And why would it be O of n? It's because we are actually using one single loop to go through the entire array and solving it like that. And space complexity is O of n also, because we are actually storing elements inside our object. So this is a pretty optimized solution, but we do have one more way. In that way, we can actually have constant space. We won't need any more space, but we will actually have a solution that is O of n log n, and that will be part of another video. So stick around for that, and don't forget to like this video and subscribe. That tells me if I did an okay job in passing this concept around. So make sure to like the video, and I'll see you guys next time. Bye bye.